Hello, welcome to another video. I have recently started teaching a course at University of Michigan with 3 other professors titled, I believe it's Open Source Impact and Innovation. And the subject for next week's lecture is the good parts of Git. And I was trying to think, like, how could I possibly summarize the good parts of a terrible system like Git, other than show off that there's really not all that much that you need to know. And so this video is going to be an attempt to show the very few commands relatively, because I think there's close to 100 subcommands of Git. The very few commands that you really need to, I would say, I don't know, could you say that I'm a Git master, I guess? I would say that I'm pretty good at it, but anyway, I'm going to jump through all of the commands that I use from Git, or at least the most common ones. In order to try and figure that out, I wrote out my shell history to this T file and then wrote a terrible regular expression. I guess I'll show that regular expression so that if you want to look at my glorious regex skills, including all the typos that I have here. And it turns out, like, the common commands that I run fall off extremely quickly. Like, you know, even reflog, which I think is a pretty important command, and we will cover it in this video, is, you know, way the hell down here. But I'm not going to cover them in this order because I don't feel like that is great for learning. So we're going to cover them in an order that I think makes sense. But anyway, let's look at the Git commands. Let's get in the right directory. All right. Okay, so the first one that I want to talk about is git clone. Obviously, you're going to start your Git journey by cloning some repository and bringing it to your local machine. Git is a distributed version control system, and so it has this concept of remotes. Like, it is a place where a Git repository can live, and you can get a full copy of that by cloning it. Typically, you're going to use git clone either most commonly one of 3 things. Either HTTPS, probably from GitHub, and it'll just look like a URL that matches this. I tend to prefer SSH clones, but you have to set up SSH keys for that. And it looks like this. So instead of :// you have git at, and instead of a slash here you have a colon, just the way that SSH URLs work out. And sometimes you'll clone file system things. So for instance, well, I don't have a copy of AST pretty there, but I don't know, I probably have PyUpgrade. And sometimes you'll clone things that are just file system. There are, of course, many other ways to clone, and there are ways to extend clone to support different URLs as well, but for the most part, those are our 3 common ones. And I wanted to show a few common options to git clone as well. Git clone itself is actually sort of a combination of a bunch of commands, and I'll show you those as well in a second. Probably the most common one that I use pretty often is depth = 1. This does what's called a shallow clone. It saves cloning the entire history of the repository and just gives you a single commit. And if we look inside here, obviously we're going to use some other git commands while we're doing this, so we'll cover git log in a bit, but you'll see here that because I cloned it at depth 1, there is only 1 commit here. And it has this grafted annotation here, which is how Git represents a place where it doesn't have the full history. It knows that there's more history here, but we've intentionally limited it to a single depth. Another clone that you might use is to clone a single branch of a repository. And sometimes this is useful for making a shorter script where you're automatically checking out a particular branch and you don't have to write 3 other commands to get there, but sometimes this is useful. Now, what is git clone sort of doing behind the scenes? Now, this is going to be a little bit, did I already delete it? Yeah, we did. Okay, it's going to be a little bit glossing over some of the details, but git clone kind of looks like a bunch of commands combined. The first is git init. This is going to initialize the repository. So let's say we were cloning that same repo from before, /astpretty, into this astpretty directory, cd into there. We are going to set up the remote. You can look at remotes by using git remote. Obviously, most of the time you're not going to use this command, but git remote add origin, and then that same URL. So this will set up the remote. So now if we do git remote again, you'll see we have origin. If we get remote-v, it tells us what that is. Next, we are going to fetch. This takes the things that are in the remote and makes them locally available. Git fetch. We'll show fetch later when we're talking about another command as well. You can see here that it fetched a few things. Some of them are tags in our repository, others are branches in our repository. And I didn't fetch with depth 1, but you could have fetched with depth 1, which is kind of the shortcut that this does here. And then finally is git checkout. Well, actually, if we're teaching the new things, we should use git switch. I'm old school, so I will still be using reset and checkout, but I believe git switch is the right one. Yeah, why did I not need to switch to it? Branch main, already on main. Well, it clearly did because it created the files here. Anyway, I'm a little unfamiliar with the new git commands that are meant to replace checkout and reset, which are admittedly a little confusing because they do like 4 or 5 different things. If you want the git checkout version of that, it would be git checkout origin/main-b, or I guess even just git checkout main. But I usually would use origin/main-b main, even though it does the same thing. But that's clone. Okay, cool. If you noticed my list of commands up at the top here, the one that I run the most often is git status. This is almost like a nervous tick for me in the same way that like I seed around directories and I immediately run ls to see what's going on. Git status is kind of my what's going on here. What do we have? You know, what is the state of the world? And I run this command a lot. It's generally useful just out of the box to show you what's going on. Usually if you have modified files, so for instance, if we put some contents in here and then ran git status, you'll see that it's modified there. Later when we talk about, actually, we'll probably just talk about it right now. We'll also be changing these files and putting them into a staging area, removing them from a staging area, and git status will help us understand that. But I guess let's do that now since it's the next one in my list. But before we do that, we'll talk about git diff. This shows the differences that exist already. And we'll actually show a git diff -- staged as well, which once we add things to the staging area, it'll show the things that are about to be committed. Git kind of has this concept of the files on disk, the changes to the files on disk, and then the changes on the files on disk that are about to end up in some sort of commit, either a new commit or added to a previous commit. And so that staging area is kind of where you say like, oh, I'm about to add these files, or I'm about to make these changes and make it permanent in a commit. But we haven't staged anything yet. In order to stage something, we are going to use git add. And there are a lot of options to git add, but we're going to go through just 2 of them today. First, let's run git status again. The first is to just send a file path in general to this. For instance, if we do git add readme, we run git status again. You can see now that it's changes to be committed. These are things that are in that staging area. We can remove something from the staging area. Well, the way that I would remove things from the staging area is by using git reset. This is the old school way to do this, but reset also has several things that it does. And so this is the old way. Let's show that it worked, but then do it the new way, which is with git restore. This is how you unstage something, I believe. No? You can tell I don't know how to use the new commands. What is the right option for this then? Restore specific paths with some context from a stores. Well, clearly I don't know. So anyway, that's for you to figure out. And I guess I'll just show you that reset does what I expect it to. Well, that's awkward. In addition to modifying the staging area, there are commands that can delete and move files around. So for instance, if you git rm, say I didn't want this file anymore, that is a way to delete the file and stage the deletion of that file. So you can see it's already in that to be committed. You can similarly move files as well. Setup.py, or I don't know, change it to 2, sure. This is again a nonsensical thing to do, but just to demonstrate git move and git rm. I also wanted to show you a good option to git add, because I frequently see people do git add dot, and that makes me nervous because sometimes you have just random junk sitting around in your Git repository, and if you git add dot, then that random junk is just going to end up inside your repository when you didn't want it from before. Let's get that out of here. Get out of here, junk random. I don't know why I did it in the other order, probably alphabetical. But usually what someone actually wants instead is to only add the files that have been changed. For instance, this README was already part of the repository before, however, these random junk files were not. And in order to do that, there's git add -u, or as my chat likes to say, the shoe, because the way I usually slur together -u is the shoe. This is life-changing command. I hope if you get nothing out of this video, that is the thing. But you'll see here that I was able to stage those changes to this file and not touch the random junk that happened to be in my working directory. Another thing that's useful for git add, and we'll actually see this, I mean, it's also for reset and checkout later, but if you have a bunch of changes to a file or a bunch of files, for instance, say we, I don't know, added some other text down here. Obviously these changes are going to be nonsensical, but I hope that the commands themselves will make sense, but I don't know, maybe we print in here as well. So you can see again, I'm running git status, sort of, second naturedly. We can again get diff to see what those patches would look like without them being committed. But there's git add -p. And what this takes you into is this little interactive mode where you can partially stage all of the changes that are in your working directory. So you can choose which parts of your patch that you want in or out of a commit. And this can be really useful if, for instance, like you have debugging stuff you don't want to commit, or you have like multiple different changes and you want to do them as, small atomic commits where you take each change set at a time. This can help you pick things in piecemeal, essentially. I think P stands for patch though, but I like to think of it as piecemeal. But anyway, you can, say yes or no, and, only stage the parts of things that you want it to. And so you can see, I said no to this other text, and maybe that didn't want that command. In the same way, you can do get reset -p, and this will allow you to unstage things interactively in the same way. So reset and add kind of opposites here. And in theory, get restore as well, but I don't know how to use get restore, so that's because I'm old. Yeah, okay, so anyway, I'm gonna quit out of this, which is Q. You can also ask for help, and it'll tell you all of the subcommands here. You can also manually edit them, although I have never had great success with this, and Git likes to call these hunks, which it's quite a word for them. But anyway, we're gonna quit out of that. Cool. Next, now that we've staged some stuff, let's talk about committing. This is kind of the second most important part of a Git repository is actually making a change set and dealing with that. And so let's do git commit. Wait, have I not talked about branches yet? Well, it's not on my list. How have I messed this up? Oh, it's at the bottom. Well, we'll do that next, I guess. So let's make a commit. Git commit is the command that you're going to use. If you run it with no arguments, by default, it's going to, well, I have git hooks set up, so it's going to do that. By default, it's going to open an editor and allow you to type a commit message here. I think by default, it's going to use VI, but I have configured my editor so that it runs my editor. And you'll make a commit message here. Typically, the first line of a commit message is the subject. So you tell what you did. So yeah, this is actually just a garbage commit, but I added some, let's see, add imperative and no subject. Added greetings to readme.md. And then below the subject, you can add additional context, usually just like a description of what you did, or leave it blank. I like to leave it blank most of the time because, if your subject is not freestanding, well, yeah, but the description can be really helpful to clarify things or add context or link a ticket or do other stuff there. But obviously this is nonsense, so I'm not gonna bother. So that's what git commit does by default. Obviously opening an editor is a lot of extra work. And so generally I'm not going through that process, and instead I'm using git commit -m with the commit message here. Commit message. Obviously there is nothing staged, so it actually did not commit here. I should just remove the git hooks. Hold on. Otherwise this is going to be really annoying the rest of this. I should have just used pre-commit uninstall. What am I doing? Anyway, if we were to add this and git commit -m some other changes, this is typically the commit workflow that I'm going to go through, where I'm directly specifying the message on the command line. I'm not bothering with the editor unless I need to add additional context below. But you can actually add additional context below by using this -m flag more than once. And this was something that one of my viewers showed me at some point. So let's actually make another garbage change here. Git add -u again, git status, just to make sure we're in a good place. You can actually add -m more than once, and it will add to the commit body instead of the original subject here. So some description. And if I do git show, that'll show the previous commit that just happened. I guess we talk about git show later, but anyway. You can see here that those two messages ended up here, whereas the commit before it, and we'll show git log later as well. The commit before it, you know, this was just the -m that I said, and this was the one that we typed to the editor. So that's git commit. There's a few other things from git commit that you might want to use. One of them I use when making a new repository. So let's say we made a new repository. It's a good practice to make an initial empty commit. That way, if you need to do any history fudging, there's at least an empty commit to do stuff on top of. However, if you try and make a commit that's empty, it doesn't let you do anything because we don't have anything staged here, but there's a helpful allow empty, which allows you to make an empty commit. There's also suspiciously, and I don't know why you would ever want to do this, there's an allow empty message option, which makes a commit that has no message. I don't know why you would ever do this, but it's there. This is not one of the useful commands in Git, to be clear, but I think it's funny, so I added it anyway. All right, I guess the only other thing that I think about with git commit is modifying a previous commit, and this is a little bit more advanced than we probably need to cover in this video, but let's say that we made that garbage commit and then we're like, actually, no, we should have done more things to it. What you can do is instead of making a new commit, you can modify the previous commit by doing git commit --amend. And by default, this is also going to open up the editor and have you edit the message. There's also amend no edit, which is just going to skip the editor for you and just, yeah, I want to put those changes into the previous commit. And so now you can see that both of those changes were melded into one. So that's kind of amend. Amends, this modifies history, so it is a destructive command. And so generally, I use it a lot, but I wouldn't necessarily recommend it for beginners. But anyway, that's amend, that's git commit. Let's talk about checkout next, which the newer commands for this, I believe, are switch and restore. But again, I am old, so I'm going to show you checkout. What checkout does is it allows you to go to a particular revision. So for instance, well, I haven't showed you tags yet, but let's just pretend you know about tags. Tags are pointers in time to a place in the Git history, and you can use them with checkout to check out that particular revision. So if I did git checkout, I want to look at version 1.4.0 of AST Pretty. I don't know why I would. I guess you could probably use git switch too, right? 1.5.0. Branch is expected got tag. Well, maybe you can't then. You can check out the particular version in time, and it'll put you into the repository. Make the code look like it was back in 2018. So for instance, we look at the setup.py here. It's exactly what it was in 2018, back when Python 2 was important and such. But that's checkout. Checkout takes any sort of revision. So for instance, you could have put this SHA there as well, even though we are already on that revision, although it doesn't produce an error message. Neat. Guess it's idempotent. Cool. But yeah, you can check out branches, tags, SHAs, etc. And symbolic references as well. So for instance, if I want 3 commits before that, I could put 3 carets there, and that happens to also be a tag version. But that's checkout. I typically use checkout for 2 things. One is to switch branches. So we only have 1 branch right now. You can switch branches with git checkout. Obviously, if you're just learning Git, I would recommend using git switch to switch branches, but this would take me back to this branch. I also use checkout to create branches, and I believe there is a git switch equivalent for that one as well. Unfortunately, I don't know it. But I almost always use exactly this format when creating a feature branch. Git checkout origin/main, or whatever your default branch is. I guess you could even say origin/head, since this is a shortcut to whatever the default branch is. And -b gives you your new branch name. And so, well, I guess you can't do that then. I lied. Why doesn't this work? It probably because I did I created this repository not with clone. There's a command for this. Hold on. Slight interruption here. Is it in here? There's like set head. Yeah, get remote set head origin auto. And now I can do it, maybe? Yeah, okay, anyway, this is normally run, we're getting into advanced commands that I don't even know. This is normally run as part of clone, but because I did the weird clone simulation, it didn't actually set this for me, so. Anyway, yeah, so I guess you can use origin slash capital head. Capital head is sort of a shortcut to default branch. How are we doing on time? Okay, good. I think we have plenty of time. I think I can actually fit this in a lecture, which is the whole reason that I'm making this video, is to see if I could fit it in a lecture. Cool. So the other thing that, you would use get switch probably because you're not old like me, but get switch allows you to switch between branches. Get checkout can also be used to set files in your working directory from some other revision. So for instance, if we wanted, for whatever reason, again, this is a nonsensical thing to do. If for some reason I wanted the setup.py file specifically from this revision, I could tell get checkout to do that. And now it is, well, it's actually staged automatically, which is kind of weird, but you can see that this is that same contents from 2018 from before. I don't use this very often, but sometimes it is useful. I think the more useful thing that I use this sort of format of get checkout and files is to, well, let's unstage that with get reset. The more common use that I use is get checkout -- dot, and this is a cryptic way to say discard all of the changes in the working directory. So you can see here that setup.py modification was removed. Obviously you can use more specific paths instead of just dot if you're, this is again like this is a command that loses you data. I've lost so much work from this command running it accidentally on the wrong repository or the wrong directory. But yes, I guess be careful with this, but this is also a way to discard changes. But for the most part, I'm always just using checkout to create new branches or switch between branches. And obviously get switch is the better version of that. And this is kind of the form that I use there. Cool. Okay, so I guess the next command that we'll get to is get push. So once you've, well, do we have a branch that's not trash? Well, I guess they're all gonna be trash. So I'll show you a push, even though I don't really want to push to a remote from garbage commits, but get commit -m, I don't know. We're not following best practices in this. We're just using terrible messages. So the next command is get push. By default, it's going to try and push to whatever's configured as your upstream. So I think I don't have an upstream configured here, so it should fail. Yeah. And fortunately, it tells you kind of the useful command. This is honestly the only get push command that I ever use. Sometimes with force, but this is if you learn one push command, it's this, and you're always going to use this. Get push takes 0 to 2 arguments, or maybe can it even take 1? I don't know. 0 arguments being whatever the default upstream is. I guess I don't configure my upstreams, but it's the remote that you're pushing to, again from get remote, and then the ref spec that you're pushing to. And by default, head points to your current branch. So I realized earlier we said head points to the default branch. That's true if it's origin/head, but here it is the local branch. I guess technically it is the local branch for the remote when you're doing origin/head, but that's too confusing. But yeah, this is the command I use. Get push origin head. This is how you take your local committed branch and put it on some other remote. Obviously, if you have permission, and in this case, it's going to be able to put it out on the old GitHub here, and then you could go through and make your pull request. Obviously, I'm not going to do that. I'm gonna delete this branch, and somewhat unintuitively, you delete a branch by using get push with a colon in front of the branch name. So that's how you delete a branch. I think there's also like a get push -- delete or something, but this is the one that I remember. And I guess I don't do it very often, so I haven't learned the better way to do it. And it's also possible that the better way to do it didn't exist when I learned this, and so I haven't bothered, relearning things. All right. The next command that we're going to learn is git pull. This allows you to retrieve and merge changes from a remote branch. So we actually have to pretend a little bit here for a second. We're going to take some older commit of main and pretend that we're on an old branch. Oh, I guess I didn't talk about git branch. Well, git branch shows you your branches, even though I ran it. And git branch-u, I believe, sets the upstream. So this is the thing I was talking about earlier. But that was just so I could run git status and have it tell me that it's 26 commits behind. That's the only reason that I do this, is so that this actually produces the right value. But anyway, let's say that we had modified this in some way. I don't know, added return false here or something. We had made a commit here, update AST pretty, breaking it, I don't know. Bad commit message, but it doesn't matter. And now I've noticed that when I look at log, which I haven't showed you yet, but it's just the log of commits. I guess I probably won't show it to you later. I also showed you git show already, so we can just take those off the list. Nice, we're making this simpler. Maybe I noticed after making this commit that I was like, wait a minute, this is from June of last year. Surely some changes have happened in this repo. This branch is out of date. Let's update it. There's kind of two main ways to update something. One is with a merge and one is with a rebase. Personally, I'm almost always using rebase, but in order to show you git pull, that is a merge, or at least by default is a merge. So what git pull is going to do is kind of two things together. Git pull is really a, oh, that's not a common character. It's really a git fetch plus a git merge. And it's kind of just magically both of those at the same time. By default, it's going to pull whatever your default upstream is. So in this case, it was not specified. And so reconcile divergent branches. This is a new message. That's probably because I don't use this command very often. So by default, it's going to try your upstream. You're almost always going to be using origin. I believe you actually need main here, or whatever the branch name is. And I guess you need to tell it how to merge. Oh man, I didn't want to have to explain fast forward. Well, anyway. I have another video on fast forward that explains this way better than I'm going to do here, but this basically told the merge, told pull to merge using a fast forward strategy. That's kind of what it's explaining here. Like either make a merge commit, make a rebase, or only do pull in a fast forward manner. Fast forward being like you're on a commit and you're only traversing forwards. Even if you've diverged, then it just fails, which is why it failed here, because I think it defaulted to this. Or it just was like, what are you doing? Didn't do any of them. But what this did here is it updated my branch. So now if we look at git status here, you'll see that I have two commits ahead of the branch that I had before. One was that commit that I made here, this updated breaking it, and then a merge commit. This is it updating from my remote default branch and merging it into mine. I don't personally use merge commits because I tend to specifically make a bunch of atomic commits on my feature branches and then replay them on top of the default branch using rebase. But anyway, for sake of describing this, git pull tends to be a fetch and a merge. We can actually do the same thing. It's actually, oh, well, we're using another command that I haven't shown yet, but we'll show it later. So actually, we'll just talk about it now. What git reset, another thing of git reset, and this is again why git restore and switch, and I think one other one that I don't remember, were added, is git reset has a bunch of different things that it does. One thing that it can do is it can change the revision that you've checked out forcibly. And so what I'm doing here is I am saying use --hard, so change the current revision that my branch points to instead point to this thing. And if I ask what head : is, this is the previous commit. This is the one where I did the breaking here. So this is going to get rid of that merge commit. Yeah, there's also git reset soft. So actually, we'll show we'll show why What you should learn before you do destructive actions like git reset, which is to look at git ref log. This is the reference log. I thought it was pronounced reflog for the longest time until somebody told me that I was an idiot. And why would I think it was reflog? I don't know. But you can actually find the revisions here of all the changes, all the commits, all the checkouts, all the merges, etc. And so, for instance, if I wanted to undo what I just did, we can go back to this one. And so now we still have that merge here. But there's also get reset -- soft. And what soft will do is it will change the revision, but keep all of the things that you have checked out. So for instance, these are the changes that happened. I guess not much changed since since halfway through last year in this repository, which makes sense. This is a pretty stable library. But often, often I use this as a cheaty way to redo a commit in a better way. But that's kind of the difference between soft and hard. Anyway, what was I actually doing here? Oh, I was going to show you the pull, but doing fetch and then merge, right? So let's go back to the world before I had run git pull. And so the first thing it's going to do is git fetch, or git fetch origin if you want a specific remote, or git fetch all if you want to fetch all of the remotes. Obviously there's no output here because we had already cloned this and fully fetched this repository. And then the next thing it was doing is git merge origin / main. And again, there's other options that you could have used here, but this is going to make a merge commit by default. Yeah, so that's git pull. I typically don't use git pull at all. I typically use fetch plus rebase or fetch plus merge, depending on which type of workflow that I'm doing. So for instance, show you rebase quickly. Rebase is what I like to refer to as a chainsaw for Git. It is extremely powerful, extremely dangerous, but when used correctly, it can be really, really helpful because it allows you to do a whole bunch of manipulation of history. And again, use reflog so you know what things you're modifying. But if I would show you my workflow, I would instead be git rebasing on top of origin main. I guess we could even do origin head. And this takes you into an interactive rebase. Normally, if you have more commits, they'll all be listed here, and then you'll be able to change the operations that they're doing here. By default, it's just going to replay any of the commits that you have, eliminating any merge commits. But you can do things like change the commit message. You can meld two commits together with either squash or fix up. You can run commands against them. You can do all sorts of other stuff. The most common things that I'm using in particular are squash, fix up, and pick. Occasionally I will do edit. Pretty rarely I'll do reword because often I'll just short circuit it and do edit anyway. But yeah, I guess there's a whole bunch of other options here. But for the most part, rebase allows you to change what the commits did and change the history. It's destructive in that you're modifying Git history that's typically supposed to be immutable. But as long as you're doing it on a future branch, it's kind of okay. But in this case, we're going to replay that one commit. And so instead of having two commits, when we do git status, the two commits being the actual commit and then the merge commit, we've actually just replayed that one commit on top of the top of the repository. So you can see here, we've rebased on top of this. We've replayed the one commit that I had here. And again, I'm trying to go quickly so that this fits within a lecture, but I have another video on rebase that you can search on my YouTube channel to find, where I go into more in-depth description of how it works, how it differs from merge, and some more fancy stuff that you can do with it. Okay, so we showed earlier git show, which is just show the previous commit. We've also done git log, which shows kind of the chain of commits that happen here. But I wanted to show you some other options to git log because I think by default the output is not that useful. The common ones that I use pretty often are git log one line. This gives you kind of a more compact view of things where you just see the hash and the subject, and the body of the commit is left out. So any of the like description information is gone. This repository doesn't see too much non-automated action right now. So obviously the commits don't look that interesting. You'll notice here that it also shows some of the references of what things were pointed at particular points in time. Does it show tags? I forget if it does by default. I don't think I made a release of this in a long time. Maybe I have? Maybe I haven't? Oh, haven't made a release of this in an extremely long time. But yeah, it'll also show tags as well by default. You can also force them to be shown with -- decorate, although one line might just imply decorate, I forget. But the other one that I use pretty often is graph, and I usually use these 3 options together. One line, or yeah, git log, one line, decorate, graph. And this can kind of show the structure of the history. So you can see like when a commit was made on a branch, when it got merged as a merge commit here. And well, this history looks pretty normally, you know, just a zipper here, but in some other repositories it might not look so zippery. Let's see, git log, graph, decorate, one line. Yeah, you can see there's some more interesting things that happen on here. Oh, I mean, maybe I'm a different size. No. But yeah, this can sometimes make it more easy to see like how the history went throughout time in case you needed to traverse in a particular way. I've shown this off in a bunch of different videos. And again, decorate is useful for showing either revisions at particular places or tags at particular places. And so that's git log. Related to git log, or I guess another option to git log, which I like to use a lot, is git log -G, capital G. This helps you find some search string and when it changed in a file. This is kind of one of my spelunking tools that I use all the time. So for instance, what's a good thing to search for? I don't know. I don't know. Have we ever used ls remote in this repo? Yeah. So this can show like when commits modified contents that had this string in them. And you can also use git log -p to show the patch that happened there. So for instance, there was a comment here that used ls remote in here that was removed. That's what capital G found, and this is the patch that was relevant to that search there. You can also see that I added some code that used ls remote here, and also see the commit and patch related to that. So git log is often useful for spelunking, and I find that capital G is the most useful option there. There's also some formatting options to git log as well that can be useful. So for instance, you know, we actually saw a formatting option earlier when we did -- one line, but you can actually control the format more specifically using -- format. So for instance, if we wanted the short SHA and the author email for whatever reason, you could, you know, use that to figure out what those are here. You could even say sort -u, or no, sort unique -c, sort -r. You could even say like, what are the most common committers in this repository through a command like this? And no surprise, it's me. But yeah, that's again, just like being able to control the format can help you, you know, figure out different information about our repository. Cool. Okay, so that's git log. That's one way to say like, you know, what was the history of this repository. Another way to sort of inspect some of the history is git blame. There's all sorts of memes about being like, oh, why is this code the way that it is? And git blame can help you answer that. And often the meme is like, man, who did this stupid thing in this repository? And then you run git blame and it's yourself. But it can show you like what commit changed a particular file, who the committer is, when I decided that capital letters were the worst thing ever, and you know what date it happened at, etc. There's also other options to this, like -w to ignore white space changes, or -e to show email addresses instead of names, and I think -m with a number to like try and find moves more specifically. But these are kind of the options that I use to blame. I actually don't use blame all that often because most of the times I don't super care who did it, although sometimes it can be useful to say like, why did this line change? Like, so for instance, we might look at this file and say, you know, when did I decide to make this use SQLite? Actually, that might be an interesting one here. So like, this commit on import SQLite 3 happened way back in 2015. Why did I decide to use SQLite? I can look at the commit here. I can look at the commit message and see like, oh, it was because of symlinks. I didn't want to use symlinks. No, the actual story was adding Windows support and no symlinks on Windows. But I can, again, use git blame to figure out more information about the particular code and then help me you know, ask the history for why this happened. Okay, we're getting more into like spelunking-ish type commands, so I'll show you two others that I use all the time. One of those is get ls files. This is just going to list all the files in your repository. By default, that's not that useful, but maybe I only want, I don't know, Python files, or maybe I only want Ruby files. There's Ruby files in this. No? Go? Yeah. You can use special patterns here to figure out what files you want. You know, sometimes I might want to edit every file that is a shell file. Yeah, sure. Oh, there's a lot of shell files, more than I wanted, but yeah. And so, you know, you can chain ls files to your editor of choice and do whatever you want here. So kind of useful, not as useful as the next command I'm going to show you, which is get grep. This allows you to search a repository. This is probably, if I had to say what my favorite command, git command is, it's get grep. I don't think anything really comes close. Well, get log dash capital G is pretty close, but get grep, this is some good stuff. Let's say, for instance, I don't know, I really don't like this constants file. This was maybe a good idea when I did this in 2014, but I really don't like this. So maybe I might want to say like, hey, how often or like where in this repository is this symbol referenced, local repo version? And so I can say git grep this and find that, oh, cool, it's in these 3 files. I can even say, you know, what are the file names by using git grep -l. I can then open those files and, you know, go to the particular line where it's referenced and search around. And you probably, I don't know, I find this really useful because I don't have go to definition in my editor. I guess maybe if you're using a real IDE, you wouldn't use git grep as often, but I find it to be really powerful, and maybe you're stuck on a machine where you don't have an IDE and you would want to use the terminal to figure some stuff out like this. But I love git grep. Out of the box, it's not as useful as it could be. I actually recommend turning on extended regex by default. I mean, in the same way that grep isn't that useful out of the box. Like, you kind of want grep-e or grep-perl. But git grep-e is pretty good. You can actually turn this on, I believe, by default. Yeah, by setting this in git config. I'm surprised that this isn't highlighted. I'll have to fix my text editor to highlight this properly. I think this one is though, right? Nope. Is my editor out of date? I shouldn't do this in the middle of the video. No, they're up to date. Okay, anyway, I'll have to figure that out later. But yeah, git grep, really useful for searching around a repository and finding things that you want. And I guess I really just have one command left. I thought this was going to be like a 2-hour video. Thank goodness it's not. And the last command I'm going to show you is git clean. I'm not going to run it in this repository because I actually need some of the stuff that's there. What is this to do? I kind of want that too. How do I find a repository that has junk in it that I don't care about? Maybe here? This is not. Oh, you know what? We'll just use the. We'll just make the junk in this repository, and that way we're not. Yeah. So what git clean by default is, I don't know what it does by default, but what it's really useful for is setting your repository back to just a complete blank slate. And I don't remember what these options do, but this is the git clean that I use all the time. Git clean ffxd. You can also dry run before you do it, and you can see like what stuff it would get rid of. But this will completely clean up your repository. So yeah, I think X is verbose mode. I think you need F twice for some reason. I don't know, but this is the one that I have memorized in my brain, and maybe you will now too. The other nice thing about this is if you had even stuff that's ignored. So for instance, well, myPyCache was ignored. These two ended up in git status. I don't know, let's run the tests and create some more stuff that's ignored. Even files that are ignored will get cleaned up as well. And again, this is a destructive test. Oh, great. I haven't updated this for 3.13, have I? Oh, well, that's for me to fix later. I swear. Oh, maybe that's because this is the old checkout? Well, I don't know. Oh, no, it's because I broke the code. That's because I broke the code. Anyway, that's not important. You'll see that git status is clean, but if we were to ask about git clean, fxfd, you can see that there's all sorts of files that were actually created as a side effect of running the test. These are often things that are in my git ignore. So for instance, like the coverage directory, the talks directory, PyC files, egginfo. Yeah, so like this directory is git ignored. This PyCache directory has PyC files in it, so it got ignored, etc. But git clean can still help you get back to that blank slate by git clean fxfd. Yeah. And that's really all the commands that I use. I mean, there are some more that I use occasionally. They're usually things that I don't use very often, things that I have to look up. Like bisect is probably another example of a really powerful command, but I probably use like once or twice a year, and really for just extremely advanced usage. And I have a video on that if you search my channel. So there's better explanations of that than me trying to quickly go over it in this one. But yeah, that's mostly it. Lately, I've also been using git catfile a lot, just because I've been trying to, well, I've successfully cleaned up a repository, and this is helpful for showing commits and stuff. But honestly, you probably don't need to know that. The commands that I showed today are, you know, the 99.9% of what I run. I mean, I think git status is already like 2.9, so yeah. Hopefully this was useful. This obviously was a little bit rambly because, I mean, this is my notes for it. I was literally just like, I'm gonna run through these commands and tell you what I think about them. And hopefully, you know, I know this is a 45-minute video, but hopefully this convinces you that Git actually isn't as complicated as it needs to be, and you can get by with a lot fewer commands than the overwhelming number that Git presents you with. And yeah, you know, I would say I'm an expert, and I barely use most of the commands. Anyway, hopefully you found this useful. If there are additional things you'd like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.